So let's have a little bit of fun talking about some ARM64 hex encoding for specific instructions. So pulled up here, I have two windows of Binary Ninja, and this is looking at recent AMOS that does things a little bit differently. And I just want to focus on specific instructions and why they may differ in two similar binaries and why that is. Okay, so at the top of this, we're not going to focus too much on the actual behavior here, but this function here is used to create a new thread, and it passes an address of the function to execute with this new thread, and this ends up then running this code, which is related to anti-debugging or debugging detection type logic. So we see the use of ptrace, which is commonly seen with this type of behavior, and then a sysctl that passes in these values to see if the binary is being debugged. So if you're trying to create a rule for this, or you're trying to see similarities between two of these types of files, if we focus on ptrace, for example, and we compare what's on this window with this window, if we go to the address that's passed in to the new thread function, and we scroll down and focus on ptrace, so Binary Ninja shows you the hex encodings for all of the instructions here, right? And they're located here right after the address. If we compare these two, we'll see that they're different. Now, if you do the comparison to everything else that's not a branch and link instruction, or most of these that are not branching, like if we look at this move for this 0x1f to the W0 register, we'll see that these are the same. We'll see that these are the same. All of these going into register. So we have W1, W2, W3. Those are all the same. So when we get to the ptrace or any kind of branch and link here, we'll see this starts with A30 or A31. We can just copy here to see it better. We'll see that these are different. They end in 0x94. We got to account Indianness here, which we'll talk about in a second, but they're different. So the question is, why is that different? And how can we use this understanding to create maybe some logic, detection logic around this? So the why. So these are both ending in 9.4, and if we want to compare, we'll see other branch and link also end in 9.4. So that's a value that we can use to basically determine that this is the instruction for a branch and link. We can compare that with the documentation for ARM. So let's go and look at some ARM stuff. So the BL instruction, branch with link, branches to a PC relative offset. This is going to be really important as we talk about why they're different. And we can see here it sets certain values that we would expect to see for this branch and link instruction. So that's binary values, which will then, if you convert that, so let's see, we have bin 0x94. We know that that's something we've seen in all of these different BL instructions. If we compare that, we look at the binary for that, we'll see that they match. So 1, 0, 0, 1, 0, 1. And then there's the, right here at 25, we have this M26, which then we can see 0, 0 at the end here. Okay, so that is a good indicator, this 9.4, that these are branch and link. That proves what we were looking for and how those are all similar, but everything else is different between these two binaries when it comes to the hex encodings. Everything at the top is different. So good thing is there's a website that we can use to convert this over, this online hex to ARM converter. So if we were to grab some hex code here, convert that, we'll see that this converts to a branch and link, and it has this value that's passed to it. So the reason we don't see that when we're looking in a tool like Binary Ninja is because this is resolved for you, right? So if we go and calculate using PC and this offset, we should get to the address of this function. Reason we're going to use PC is because it branches to a PC relative offset. PC in this case is going to be the address of the instruction that you're currently on. So let's grab this offset and we're going to compare it. So let's just put it here so I don't lose it. And then we're going to just make a calculation using PC, which PC is going to be this address, right? So the address of the current instruction. And we go over, let's convert this to hex to make it easy to see. So we're going PC plus the offset that was in the encoding for this instruction should give us the address of this function. Press enter. Oh, you have to add 0x here. So that is 6F38. Now if we hover over sysctl, we'll see 6F38 as the address of this. We can also double click on this, and that matches what we saw, 6F38. So same thing with the other one. We have this sysctl call. We want to understand why it's different than the other one. It's because the offset will be different. We can grab the offset and same thing. So plus, let's get the PC. Make sure I don't forget the 0x here, hex. And now that's going to calculate using the PC, the program counter. So it's going to be the address of the current instruction plus the offset that's inside of the hex encoding for this. Calculate that, that's 6FC8. We hover over sysctl, we'll see 6FC8 is the address of this function. If we double click on that, we'll get to where this is called. So just to recap, the reason that these are different is because the branch and link instructions are PC relative, and that may be different in different binaries that you're looking at, which will then change the values inside of the hex encodings at the top of this. We know that 0x94 is going to be for a branch and link instruction, so that should be constant throughout all these branch and link instructions. But if you're wondering why these might be different, when you're looking at the hex encoding for the same branch and link and everything else appears the same, that's because the PC is going to be different and the address of this is going to be calculated and that offset is going to be different, which changes the encoding. All right, well, just a quick video on that because I think it's pretty interesting to look at that. Awesome.